Let's continue with 9.5, talking about the cross product. So in the previous video, we showed looking at three-dimensional vectors. Now the cross product is going to help us find a vector that is perpendicular to the two vectors that you apply the cross product to. This doesn't mean that the two vectors you start with are perpendicular to each other, but the cross product will find a vector that's perpendicular to each one of them, and we can do that by using this sort of formula. This is very similar to something we do with matrices later on. So the cross product of two vectors finds a vector perpendicular to each one. And this is how it works. So let's establish our two vectors, whether that be ijk or using that inequality symbols. And you make this grid here where, depending the order of your cross product, your first vector, you write a row with the ijk vector. Your second row has your first vector that you're doing the cross product with, and then the third row is the second vector. Now if this order switches, of course, then the order of the rows would switch. And this is sort of the algebra that you take. Now there's a couple key things you have to watch out for. One is this plus or minus pattern, and that has to do with the signs that we have in each one of these terms. So the way it works, we essentially are doing what you would call the determinant of a 3x3 matrix, but we don't call that here. We call it the cross product. So what's happening is we start with I, and then we use J and K. So we start by eliminating the first column, first row. And if you notice, that first column, first row has I in it. And then it follows that we have to apply something known as a determinant, but we haven't talked about that yet. But this formula shows us how we're supposed to do that. And we take this smaller square after we eliminate the first column, first row, and then you're going to multiply diagonally both. So you're going to do like this cross multiplication. So that's how you notice a sub 2 times a sub 3. That's this diagonal. And then you have b sub 2 and a sub 3, and that's this diagonal. Now the thing to remember is this, I guess you would say, backslash. You have to multiply this sort of in this diagonal fashion, in this like negative slant, I guess you can say, and subtract it by this forward slash direction. And we do that for all of them. And then we move on to the next column, next row. That one is going to have a minus in front of the first term, and that's going to be being multiplied with J. But then if we notice, if we eliminate this middle column, that leaves us with this square that I'm going to multiply, again, do this cross product. So a sub 1 would be sub 3, and that's this first term inside this parentheses, minus b sub 1 times a sub 3. And lastly, last column, first row, this square here is a sub 1 times b sub 2, and then minus b sub 1. Oops, I made a mistake. This should be b sub 1 times a sub 2. Did a typo when I wrote it. Again, that's all that's happening. Just imagine you're getting rid of first row, first column, and then cross multiply, and then subtract the products from each other. And every column, you go through each column, multiply, subtract. And then the last column, multiply, and then subtract the products from each other. And what happens here is, of course, we're left with an I, J, K vector. And that vector is going to be perpendicular to A and perpendicular to B. And that's going to be the vector C, or orthogonal, if you saw the last video. So then we try to find the cross product. So this would be doing the cross product. So like I said, we start with our I, J, K column, and U is on the left side, right? So that means it's going to be my second row. And I'm only going to write the coefficients, so 2, negative 3, and 1. And then we have 4, negative 1, and 5 from V. And then we're going to start with I, and we're going to get rid of first row, first column, first row, and I'm going to cross multiply. So that's going to be negative 3 times 5 minus negative 1 times 1. And then our second column, now we have our minus J times 2 times 5 minus 4 times 1. And then plus our last column, K, is going to be 2 times negative 1 minus 4 times negative 3. Almost running out of room here. I squeezed it in there at the end. And this, for the sake of time, is going to simplify to negative 14i. And then you can pause the video and do these multiplications if you like. And then it's going to be minus 6j plus 10k. And again, you can always rewrite back into this format if you want, right? Be comfortable being able to go back and forth. But really quickly, just so we can see the first one, that of course is negative 15. And then of course that becomes positive. And then 1 times 1 is 1. And that's where we get the 14 from, the negative 14. And you do the same by just multiplying everything out. Again, it's this vector is now perpendicular to U and perpendicular to V. And if you wanted to test if they are perpendicular to each other, well, remember what I said, that two vectors are perpendicular to each other if their dot product is equal to 0, because that gives a 0 in this numerator of that dot product, and that's what ends up giving us 90 degrees, which is showing that they're perpendicular. So you can test it by just taking this vector and U and doing the dot product. Remember, where you multiply each component, corresponding component, and then when you add the components to get those products, you should get 0, and the same thing should happen for V. Now you can pause the video and try this next example and doing A cross B. But we'll just do it here. You can pause and try it, but I'm just going to continue working through it. So my first vector is A, so it's going to be 2 minus 3 and 1, negative 2, 1, 1. And I'm going to have first column is I times negative 3 times 1 minus 1 times 1. And then minus J which is going to be second column. That's going to give us -2. No, it's going to be +2. +2 times 1 minus, right, we have to multiply accordingly, minus -2 times 1. That's I, and then plus k. Last column, right? Don't forget this minus, right? Don't forget this pattern, plus, minus, plus. So make sure you put that minus here for that j. Now to going back to k, last column is going to be 2 times 1 minus -2 times -3. And then that's going to give us -4i. The second one, 2 times 1, this becomes positive, and then there's a minus, right, for that I, so it'll be -4j. And then here we have 2. -2 times -3 is +6. 2 minus 6 is -4. And again, this is just coincidence that they're all 4. Or you can put -4, -4, and -4. And you can test if they are perpendicular to each other by just doing the dot product. And if the dot product gives you 0, then you have found a vector that is perpendicular to each individual vector. But that's it. Just because we did talk about finding an angle between two vectors, then there's we can actually find this 90-degree angle. We can find a vector that makes a 90-degree angle to each vector. So this was a short one. Again, and that's all I'm testing you on. I'm not. There's maybe little small nuances, but this is what I'm looking for, being able to just do this arithmetic to find that vector. And understand that the vector you're finding makes a 90-degree angle between each vector in question. Thank you.